Dear students, welcome to Impulse Masterclasses, an innovative program designed for 10th class students. I'm Yohan, Zoology lecturer, having 27 years of experience, and I'm one of the Telugu Academy textbook authors. At present, I'm working in Impulse, Hyderabad. In today's masterclass, we are going to discuss about the blood flow in blood vessels. Let's have a look at the question. In which of the following blood vessels the blood flow is faster? Option A, arteries. Option B, capillaries. And here I am giving two clues. Fact number 1, law of continuity. It states that the fluid flows faster when the diameter is small. Fact 2, diameter of arteries is much greater than the diameter of capillaries. And based on these two clues, just imagine in which blood vessel the blood flow is much faster. When I ask this question, most of the students, they'll get confused. They'll think that as the capillary diameter is very less, the blood flow is very fast. But that is not true. Here in capillaries, the blood flow is very slow when compared to arteries or any blood vessel in human body. In this video, let's see what is the reason for this. In order to understand the reason for this, we need to understand law of continuity, arteries, veins and capillaries. Let's start with the law of continuity. Law of continuity states that when the diameter decreases, speed increases. This can be explained with simple two examples. Here I have taken two pipes with varying diameter, diameter 1 and diameter 2. And both these pipes are connected to two different taps with the same water flow. When we look at the flow of water in these two pipes, the flow of water in pipe 1 is lesser than the pipe 2. That means V1 is lesser than V2. In the same way, when water is passing through this pipe, you can find the variation in velocity. Here, V1 is less than V2, V2 is less than V3, and finally, the water come out with great speed. Let's have a brief account of blood vessels. Here, blood vessels constitute arteries, veins, and capillaries. You know that arteries carry blood away from the heart towards the tissues, and veins collect blood from tissues and carry towards the heart. And here the largest vessel arising from the heart is aorta, and this aorta on its way break up into small branches called arteries, arterioles, and finally break up into small branches called capillaries. And these capillaries again join together form small branches called venules. Veins together open into a largest veins called vena cava, who finally opens into heart. When we look at the structure of arteries and veins, both their walls is basically made up of three layers. Outer tunica externa, middle tunica media, inner tunica interna. Tunica externa consists of fibrous tissue with collagen fibers, media with elastin fibers and smooth muscles, and interna consists of squamous epithelium. And same layers are also found in the wall of vein, but the tunica media is very thin, hence the thickness of wall is less and the lumen is broad. Coming to capillaries, here in capillaries only one layer, that is tunica intima, is present with a special type of epithelium called squamous epithelium, and this squamous epithelium play an important role in exchange of nutrients and gases between blood and tissues. Based on this, it is very much clear that capillaries are completely different from arteries and veins. The responsibilities of arteries and veins is simply to carry blood from one place to other place. Whereas capillaries, they not only carry the blood but also play an important role in exchange of gases between tissues and blood. For this purpose, the blood need to flow very slowly compared to arteries. It seems to be violating law of continuity. Now I'm going to explain why this deviation has happened. To understand this, look at these two pipes. Both are same, except the second pipe is having small pipes inside. According to law of continuity, here in this pipe, V1 is greater than V2. Similarly, in pipe 2, V1 is greater than V2. In pipe 2, irrespective of the small number of tubules, the velocity is slow, similar to pipe 1. And why the velocity is slow compared to here? Because the total cross-sectional area here is greater than the cross-sectional area here. Now I'm going to tell you the fact. The total cross-sectional area of capillaries is much greater than cross-sectional area of artery. And we apply this fact in this diagram. Just imagine this is an artery and all these are capillaries. Now the total cross-sectional area of capillaries is much greater than arteries. Hence the flow of blood is very slow, as we already discussed. Students, now it's time to solve a problem based on the explained concept. Look at this question. What would be the speed of the blood flow in veins when compared to capillaries? Is the speed decreases or increases or no change? If you know the answer, please share your answer to Impulse WhatsApp group. We'll provide you video explanation for this. See you next week. Thank you.